Hey guys, what's up? So today we're going to actually be looking at square numbers, and we're also going to be looking at prime numbers. Okay, so let's start off with the square numbers. And it says in mathematics, a square number or perfect square is an integer that is a square of an integer. In other words, it is the product of some integer with itself. For example, 9 is a square number since it can be written as 3 times 3. All right. So let's just look at some square numbers. Let's look at 1 times 1, which is equal to 1. Let's look at 2 times 2, which is also a square, which would be equal to 4. Let's look at 3 times 3, which is equal to 9, as the example said. And then 4 times 4, which is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. Okay, so if you knew your timetables, you would pretty much know these square numbers by heart. But let's just write a set for it. Okay, so let's say we have a set S, which is equal to the square numbers, right? And we can write the set as 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144, and so on and so forth. So you can have 13 squared as well. So basically, any number, right, that you square is equal to a square number. Okay. Right. So there are many other square numbers. Obviously, this set goes on infinitesimally, right? So it goes on forever. And that's pretty much what square numbers are. It's just a number squared. So 2 squared is equal to 4. Anytime you multiply a number by itself, it would be considered a square number. Okay? Not too bad. All right, so let's move on to prime numbers. All right, guys, great. So let's look at prime numbers. Okay? So it says a prime number is a number that can only be divided by 1 and itself without leaving a remainder. Itself and 1 should be the only factors. Okay, so there are many numbers like this. Let's just start off with the first prime number, which is 2, right? So 2 can only be divided by 1, right, which would give you 2, and 2 divided by 2 would also give you 1. Okay, and there are no other numbers that can divide 2 and give you a whole number with no remainder. Okay, so 2 is a prime number. Okay, and let's have a set P here, where P, the set P, would be the set of prime numbers. Okay, so let's start off, and we have 2 here, which is the first prime number. Okay, now let's look at the next prime number. Okay, now the next prime number is actually 3. Okay, so let's say we have 3 divided by 1 here. We're going to end up with 3, and 3 divided by itself, we're going to end up with 1 as well. If we divide 3 by 2, we'd actually end up with 1.5. So this leaves a remainder. So clearly 2 is not a factor of 3. So 3 is also a prime number. Okay, so let's put that here. Let's try 4. Okay, is 4 a prime number? All right, so that's a good little question there. Is 4 a prime number? So 4, it can be divided by 1, which will give us 4, right? 4 can also be divided by 2, which will give us 2, and 4 can be divided by 4, which will give us 1. So there are 3 factors here, right? So clearly this is not a prime number because, remember, itself and 1 should be the only factors, and 4 has 3 factors, which is 4, 2, and 1. So clearly 4 is not a prime number, okay? So we can go on here with a ton of prime numbers. The last one I'm going to do here is 5, okay? Yes, the last one I'm going to do here is 5. Let's look at 5. 5 can be divided by 5, which will give you 1, and 5 can be divided by 1, which will give me 5, right? And there's no other case that I can use to divide 5 and I would get a whole number, right? Let's divide 5 by 2, I'll get 2.5. So clearly the only two factors for 5 are 1 and itself, right? So yeah, 5 is a prime number, okay? So it's kind of good to know all the prime numbers by heart, okay? Well, not all of them, but the initial ones, okay? Because they're pretty common, okay? So I'm just gonna write them out for you. 2, 3, 5, 7, 11, 13, 17, and 19. And 19, right? 23, 29, 31. 37, 41, 43. And so on and so forth, right? So when you need to find a prime number, pretty much all you need to do is try to find the factors. So pretty much just like the factor video that we did before, let's say you have 1, 2, 3, 4, 5, 6, and so on down here. And for 13, we're going to try to find all the factors. So we know that 1 multiplied by 13 would give us 13, right? And then we try 2. Can 2 divide into 13 without leaving a remainder? No. Can 3? No. Can 4? No. Can 5? No. Can 6? No. And you know, you'd go on. 7 can't, 8 can't, and it's kind of really obvious that the only two factors you would find is 1 and 13. And that's kind of the and that's the system you would use for prime numbers, right? You would just try to check to see which numbers are actually right. So you check to see which numbers are actually factors. Okay. So prime numbers can actually get really big. You know, they can really get really big, but genuinely for CXC, you're not gonna use much, you know, very big prime numbers. But all you have to do is go through the same videos for like factors earlier and find all the factors. You know what I mean? Take your time, and when you find all the factors, you'll eventually realize that the only two factors are 1 and itself, so you know it's a prime number. Okay? And great. All right, guys, fantastic. So we're finished this video, and in the next video, we're actually going to look at composite numbers. Okay. All right, guys. So that's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.